We are going to see three cases. We will see three cases on how to calculate the work done by a gas or the work done on the gas. So the first case is, we know that this is already the definition. We have already derived that the work done on or by the gas is given by the product of pressure and volume change. So here we will have three cases. If the volume change in volume is positive, if you get a positive answer, like if it is like expanding, if the volume is increasing, now if there is a volume, if the volume is increasing, or if the gas is expanding, then the work done is positive. Then work done is positive, which means that the gas is doing work on the piston. That means the gas is now this means the gas is doing work on the piston. This is the first case. This is a case where we have a positive work done. So we get a positive work done if the volume is increasing or if the gas is expanding. That means the gas is now, for example, if you have a container filled with gas, so there is here gas is inside this container. So in this case there is a piston here. So the gas is expanding means the volume will rise. The volume is rising. So the volume is increasing. So in this case there is work done. This, like the gas is doing work on the piston. There is a positive work done. So when the volume of the gas is increasing, or if the gas is expanding, now we get a positive work done, which means the gas is doing work on the piston. That's the first case. The second case is when the gas is contracting, or the volume is decreasing. If the change in volume is negative, it means the volume is decreasing. The change in volume is negative. That means we will have a negative work done. That means the work done is negative. So we have, so then the work done, if then is negative, then the work done is negative. We have a negative work done. That means the negative work done. That's so the work done by the gas on the piston does work on the gas. So the work done by the gas on the piston is negative. So the piston does work on the gas. This means the piston is now, therefore, the piston is now, we can say that the piston is now doing work. The piston is now is doing work on the gas. So the second case is, this case where the gas particles are contraction. In this case, the particles are becoming close together. Thus the volume is decreasing. So when there is a decrease in volume, that means the piston is exerting pressure on the gas so that its volume decreases. So in this case we have a negative work done, which means work is done by the piston on the gas. That's the second case. And the third case is if the volume remains the same, if the volume doesn't change. If the change in volume is zero, that is, the volume remains constant. The volume doesn't change, or the volume remains constant. What about if the volume doesn't change, or if the change in volume is zero? That means the volume remains constant. That means no work is done. This means, so this means no work is done. So we don't have change in volume. So change in volume zero. Whatever the pressure is, zero multiplied by pressure will be zero. So this means no work is done. That means no work is done, or no work is done on or by the gas. This is a third case. This looks like as if if we apply some force on a given object, and if the object doesn't move, if the force is unable to move the object, so we can say that no work is done by the force. Same way, if whatever force we apply, whatever pressure we apply on a given system, if we don't get any change in volume, that means there is no work done on the gas, or no work is done by the gas. This is this looks like applying a force. This is similar with applying a force, like if you have an object and if you apply some amount of force, if this force cannot move the object, so the work then is now we are exerting force, but this force cannot set the object to move. So in this case the work then is zero. Even if we apply a force on a given object, and if the object remains in what it was, so, or if the object doesn't move, no work is done by the force. Same way, if we don't have any change in volume, so no work is done or by the gas. That is what you have to know here is this is very important. Know that this is very important. So here what you have to do is, like we here to say that work is done by this force, the object has to move in the direction of the force. Look, work is done by this force on the block, provided that this force moves the object some distance in the direction of the force. Same way, work is done on, or work is done, this is very important, work is done on or by the gas if and only if the volume changes. This is a very important point that you have to know. If the volume changes, or if there is change in volume, otherwise no work is done if the volume doesn't change. Like no work is done by the force if the object doesn't move. Well, we say that work is done if the applied force sets the object to move in the direction of the force. Likewise here we say that work is done on or by the gas if the volume of the gas changes. Otherwise, if the volume remains constant, nothing is done, or no work is done by the force applied. Now let's see some an example on this question. Let's see some examples on this idea. Let us solve some example. The first example is an engine cylinder has a cross-sectional area. This is area. Cross-sectional area of 0.010 meter square. How much work can be done by a gas in the cylinder if the gas exerts a constant pressure, this is a pressure, Pascal on the piston, and moves the piston a distance of 0.04 meter. So what are the given quantities? Let's list down the given quantities now. The area is given. Area is 0.01, you can forget the 0 meter square, and the pressure is 7.5 multiplied by 10 to the power of 5 Pascal, and the distance traveled by the distance is 0.04 meter. So we want to find what's required is we want to find work done. We are asked to find the work done. Then solution. Now let's solve. We know that work is defined as force multiplied by distance, or you can write as force. You can write as force is now. I can write as force over area, as I did, which is times area times distance. So force divided by area is pressure. So it will be pressure multiplied by the area multiplied by distance traveled by the object. Because A, I can cancel out this A by A. Finally, I will get force multiplied by distance. Now let us substitute the given now. Pressure is already given. That's 7.5. It's 7.5 multiplied by 10 to the power of 5 Pascal multiplied by Now the work done by this gas is now substituting the pressure. Area is already given, that's 0.01. You can forget the units. That's 0.01 multiplied by the distance traveled, that's 0.04. So this 0. I can write it here. I will write it here. Now I forget the units. Finally, I'm going to write it in joule because the unit of work is joule. So let's multiply all this. Then let's use calculator to find the product of all these numbers. That is 7.5. 7.5 multiplied by 0.01 multiplied by 0.04. This is equal to 3 over 100,000. Sorry, this is equal to 3 times. This is 3 multiplied by 10 to the power negative 3 multiplied by 10 to the power 5. The unit of work is joule. So this is how you add the exponents. Now you take 3. They do have the same base. These two have the same base. Then we add the exponent. We add these exponents. So it will be 3 times 10 to the power of 2 joule. This is the total work done by this gas inside the cylinder. That's the work done. Now let's move on to the second example. Let's move to the second example. This is a total work done. By the way, let me show you where this unit comes from. Pascal means Newton meter per meter square. Multiplied by the SI unit of area as meter square. Multiplied by the SI unit of distance meter. Now I will cancel out this by this. Finally, I will have Newton multiplied by meter. So Newton multiplied by meter is joule, which is the SI unit of work. Understand? So the SI unit of work is joule, which is equal to the product of Newton and meter. Thus Newton multiplied by meter gives us joule. Let's move on to second example. A gas in a container is at a pressure of, there is a pressure is given. The pressure inside this gas is, now a gas in a container is at a pressure, this is a pressure Pascal, and the volume of 4 meter cube. So what is the work done by the gas if, so pressure, now let's write down the given quantities now. We know that the pressure is now, the pressure in this container is 1.6 times 10 to the power of 5 Pascal. And the volume is now, the volume is 4 meter cube. Now, what is the work done? Now we want to find the work done. Now our target is we want to find the work done. We are asked to find what's required is we want to find the work done. In both cases, we are asked to find the work done. Now let's solve the work done now. Let's start with A. What is the work done by the gas if it expands at a constant pressure, and that pressure to twice its initial volume? So that the volume will be twice, means it will be 2 times 4. So the work done is now pressure multiplied by change in volume, which is now the pressure is 1.6 times 10 to the power of 1.6 multiplied by 10 to the power of 5 Pascal, means Newton per meter square, multiplied by volume. Now it expands to twice its initial volume. Now the final volume will be, so final volume, what is the work done by the gas? It's the volume. So gas got at the pressure of this, and the volume, this is the initial volume. So it expands at a constant pressure to twice its final volume. It's expanding, the final volume will be twice, then it will be 8 meter cube now. So now what the change in volume now? Final volume is 8, initial volume is 4, so the change in volume will be 8 minus 4, which is the change in volume. Then from this change in volume will be 8 minus 4, which is 4 meter cube. So that's 4 meter cube. So meter square by this cube will cancel out now. 1.6 times 4 will be 24. 6.4, this will be 6.4 multiplied by 10 to the power of 5 Newton multiplied by meter will be joule. This is the work done. So this much amount of work is done by the gas in order to expand. Second one, let's solve B. B is now what will be the same thing if it's compressed at a constant pressure to 1/4 of its initial volume. Same way, work done is now pressure multiplied by here, by the way, we get a positive work done. This means the gas is doing work on the piston, that's the meaning, on the container, that's the meaning. So positive work done means pressure work is done by the gas. But in this case, let's see, work done by this gas, which is pressure is the same, that's 1.6 multiplied by 10 to the power of 5 Pascal. Pascal is Newton per meter square. It's Newton per meter square multiplied by change in volume now. The final volume is 1/4 of its initial. The final volume is now here. The final volume is now 1/4 of its initial volume. That's 1/4 multiplied by 4. That will be, this is equal to 4 by 4 will cancel out. This 4 will cancel by this 4. We will have 1 meter cube. That's the final volume. So the change in volume is what now? Final volume is 1 meter cube. Then the change in volume will be, final volume is 1 meter cube minus 4 meter cube. It's now compressing. That will be -3 meter cube multiplied by -3 meter cube. Now cancel out, simplify the units, meter square by this. So the work done is now, the work done is equal to now 3 times 6, 18. 4 negative, this is -4.8. This is negative work done, that's 10 to the power of 5 Pascal. This means we get a negative work done, which means work is done on the gas, that's the meaning. So here we have a negative work done. In the first case, the volume is expanding, so we have a positive work done. In the second case, the volume is decreasing, it's compressed, so we will have a negative work done. So we have two cases now. A negative work done, that's when the volume is decreasing, that's the gas is compressed now. So gas is compressing means the volume is decreasing. So this means work is done by external factor on the gas, that's the meaning. In the second case, we are asked to find the work done by the external factor. So work is done on the gas because we have a negative work done. But in the case of this A, in the first case, the gas is expanding. That means we will have the volume is increasing. When the volume is increasing, the change in volume will be positive. That means we will have a positive work done, which is equal to the work done by the gas on the piston or on the container or on the external factor. That's the main. So these are the two questions where we have a positive work done and a negative work done. That's all.